Assalamu alaikum. I am Dr. Abrar and today I am going to teach you stoichiometry, and in stoichiometry we will talk about percentage yield and molar calculations. Here in this lecture we will study and we will understand how percentage yield is calculated and how the moles are calculated. So stay with us and subscribe my channel, share it with other students. Let's start. I am starting my lecture with an example. Suppose 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia. So this is a balanced chemical equation. This equation represents the ammonia-Haber process, very famous chemical reaction when nitrogen reacts with hydrogen to form ammonia, NH3. This is the formula of ammonia. And this is the balanced chemical equation. I wrote it for the balancing these numbers. The numbers written in red: 1 mole of nitrogen, 3 moles of hydrogen. They react to form 2 moles of ammonia. Now, suppose this balanced chemical equation helps us to calculate the molar calculations and to calculate how much nitrogen is required to form a particular amount of ammonia. Suppose the question is given that if 56 grams of nitrogen is used, how much ammonia should be obtained? If this is the question, so in order to find out that if the amount of nitrogen which is given, which is provided, is 56 grams, so how much ammonia is produced? So we are dealing with these two things, nitrogen and ammonia. Now for this we will always use the basic formulas for molar calculation. The most common formula which is used is number of moles is equal to mass divided by molar mass. So now the molar mass of nitrogen, N2. What is the formula of nitrogen gas? N2. So N2, where the atomic mass of nitrogen is 14, and in every nitrogen molecule, how many nitrogen atoms are there? 2. So 14 multiplied by 2, it means that molar mass of nitrogen is 28 or 28 grams. So if 56 grams of nitrogen is used, so in terms of moles, how many moles of nitrogen are there? So we will calculate by this formula. Number of moles is equal to mass divided by molar mass. So number of moles is equal to, now the mass given is 56 grams. The mass of nitrogen given is 56 grams. And the molar mass of nitrogen which we calculated is 28, because 14 2s are 28 and 2. So atomic mass of nitrogen multiplied by 2. So here it is the molar mass of nitrogen. So when we applied these two values in the formula, so we found that the number of moles of nitrogen are 2, which are being used in this chemical equation, in this situation. In this situation, now which two values we are dealing with? Nitrogen and ammonia. So write down these two values, separate these two values in this form, in the form of two columns you can say. So nitrogen and ammonia. So according to the balanced chemical equation, if 1 mole of nitrogen is used, so how many moles of ammonia are produced? 2 moles. So 1 mole of nitrogen, here we are writing 1 mole of nitrogen, so 2 moles of ammonia are produced. So if now the number of moles in hand, the number of moles available for nitrogen are 2, so then how much ammonia will be produced? We will calculate, we will find out by ratio method. This is X. I wrote here X. So if 1 mole of nitrogen, so 2 moles of ammonia. If 2 moles of nitrogen, so 4 moles, double, because 1, the double is 2. So 2, its twice is 4, or you can calculate it like this. 1 multiplied by X and 2 multiplied by 2. So 2 multiplied by 2, it will become 4 moles. It means that if 2 moles of nitrogen are taken, so we are expecting that 4 moles of ammonia will be produced. 4 moles of ammonia will be produced. Now in terms of mass, how much mass in grams will be of ammonia? For this, once again we will use the formula, number of moles is equal to mass divided by molar mass. Here mm means molar mass. So now the number of moles of what? Ammonia. Now we are dealing with ammonia. Number of moles of ammonia. So through ratio method, how many moles of ammonia we calculated? 4 moles. So write the values then and there. Do not, I suggest, do not use new formulas every time. Use the same formula and put the values then and there in the formula. This is the easiest way to calculate. So now the number of moles are 4 and mass is unknown. We have to find out. And the molar mass of, what is this 17? This is the molar mass of ammonia. How did we calculate it? So let's say we know that the ammonia NH3, formula of ammonia is NH3, where the mass of nitrogen is, atomic mass of nitrogen is 14 plus atomic mass of hydrogen is 1, multiply by 3. Why multiply by 3? Because there are 3 atoms of hydrogen. So 3 ones are 3 plus 14 is equal to 17, or you can say 14 plus 3 is equal to 17. So what is the molar mass of ammonia? 17. Now we apply this molar mass in this formula, and in this way 4 is equal to mass divided by 17. So this will be multiplied together, 17 multiplied by 4 or 4 multiplied by 17. In this way the answer is 16. In this way we found the mass of ammonia, which is expected, which we expect that if, for instance, 56 grams of ammonia, if 56 grams of nitrogen is used, so 68 grams of ammonia should be produced. This is our theoretical value. This is our theory. We calculated, we are expecting, we can call it expected value or theoretical value, because we calculated according to our theory that if 56 grams of nitrogen is used, so we should obtain 68 grams of ammonia. This is our expected or theoretical value. Now come to the percentage yield. After molar calculation, now I will explain how to calculate percentage yield and what does it mean. So let me first tell you the formula of percentage yield. Percentage yield is equal to actual yield divided by theoretical yield, or you may call it actual yield or practical yield divided by theoretical yield or expected, multiplied by 100. I repeat, percentage yield formula is percentage yield is equal to Actual yield divided by theoretical yield multiplied by 100. Now remember that whenever we are calculating according to our theory, so we get theoretical yield. This is our theory. Our theory is saying that if we use 56 grams of nitrogen, we should obtain and we will obtain 68 grams of ammonia. We are expecting it. This is our theoretical value. This is our theoretical yield, because we calculated this value through our theory. So let's say we can call it actual yield, or we can call it actual value, and we can call it theoretical yield, or we can call it theoretical value. The words can be changed, but the concept is same. Now, for instance, what our theory is saying, that the mass of ammonia which we are expecting is 68 grams. Our theory is saying that, so here I will write 68, because according to our theory, if 56 grams of nitrogen is available, we should obtain 68 grams of ammonia. So our theory is saying it is 68 grams, but it never happens. We do not get 100% results. So remember that all of the reactants will not react to form complete product. Some of the reactants will remain unreacted. Maybe the condition is not ideal, or no matter whatever you try to make the conditions ideal, put the catalyst and your temperature, try to make it perfect as according to the requirement of the reaction, or pressure, keep it according to the requirement, but even then all of the reactants will never react together to form product. Some of the reactants, maybe 20%, maybe 25%, maybe 30%, they will remain unreacted. They will not turn into product. Successful collision is not always 100%. Therefore, you will not get 100% result. So in case, for example, now it will be given in the question that the actual yield or actual value of ammonia which you obtained through this reaction is 51 grams. This is the actual yield which will be provided. Suppose this is the next part of the question. If this is part B, if this is part A, where we calculated the amount of ammonia which is expected through molar calculation, and the part B is that actual yield is given in the question, and now you are asked to find out the percentage yield. So actual yield is 51 grams, but according to our theory is saying that we should obtain 68 grams of ammonia. Multiply by 100. So when you will put these values, you will find that the percentage yield is 75%. What does it mean? That the success rate is 75%. It means that we will not get 68 grams of ammonia. We will get lesser, that is 51. It means that the success rate, the percentage yield is 75%. So this is the concept of percentage yield. I hope you understood this lecture. Thank you very much. Thank you for joining.